Good morning, everyone. So my topic is about an operating system called FreeBSD, and mainly we title it as FreeBSD is not Linux. So I'm actually a FreeBSD developer, and more importantly, a conference hopper and repeat offender. So I work as an network consultant, and for large-scale BSD system deployments, and definitely a professional paranoid. So what is FreeBSD? FreeBSD is a full complete operating system. Those people who are coming from a Linux background, you know that Linux is actually a kernel only. And beside that, if you are talking about the distributions, so if you go into a distrowatch.com, you can find hundreds and maybe thousands of Linux-based distributions. So what is a Linux distribution? Linux distribution is actually a mixture of the kernel developed by Linus Torvald and some of the GNU tools developed by Richard Stallman. So people, organizations, and big name companies, they actually come up with the kernel and with the tools from Richard Stallman and try to build up an operating system. In FreeBSD, FreeBSD actually itself has its own kernel, own device drivers, and own tools. And more importantly, FreeBSD as usual is open source. It has got more than 24,000 third-party open source. Nowadays, I think it's more than 30,000 third-party open source software packages. They have got a full complete documentation. The community is actually very open compared to other community from different Linux distributions. So who uses FreeBSD? If you have heard the name of NetApp, Dell, yep, they are using FreeBSD. If you are using iOS, Apple iPhone, or maybe Mac OS, so in that cases, Apple is actually using a subsystem of kernel from FreeBSD. Then there is Liveline Networks. Then Microsoft actually used FreeBSD in some of its Hotmail service, WhatsApp. Juniper Networks, JuneOS is actually running based on FreeBSD system. There is Sony. If anyone is playing games in Sony PS4 or PS3, yep, that is also runs on FreeBSD. There are McAfee, Yahoo, and there are lots of companies running and developing systems based on BSD. Even if someone have actually run Panasonic smart TVs, I think it was some Viera series that also actually run on FreeBSD. So why should we use, or why someone should use FreeBSD? Due to their innovation, the great tools, they have got a very matured release model. They have got some excellent documentation in lots of languages. I'm exactly not sure if there is support for Indian languages yet, but I have seen some people contributing to the Bengali documentation. Besides that, like here is an example of the entire handbook on of FreeBSD on Chinese language. This is actually based on Mandarin. The FreeBSD license, that is the BSD clauses. There are three different variants of it: BSD 2 clause and BSD 3 clause and BSD 4 clause. Those are really business-friendly license, and as you see, that they have got a very open community. So as I was saying, that it produces a whole system, the operating system. It includes the device drivers. It has got their compiler tools and associated tools. Like in previous, it used to use GCC-based compilation system compilers, but nowadays it has moved away from GCC-based tools, and it has got LLVM-based system using CLang for the for bootstrapping the entire kernel in CLang. They have got debugging tools like GDP. They have got editors like not the VIM, but we use the basic editor that comes up with FreeBSD is actually NVI. They have got a very robust packaging system. We no longer use the source port, the port system, but port system is actually used behind the backend. But nowadays, the newbies, they can actually use the binary package system. So you are ready to code when the installation is done. So these are some recent changes which have taken place in the recent years, and sometimes what happens is people start thinking about FreeBSD 4.11, but nowadays we are no longer like that. FreeBSD 11, that is much more matured, and it has got a lot of way from that FreeBSD version 4.11. So as I was saying, that we have gone into binary package manager called PKG system. So what happens is everybody, we are actually developing the ports, and from the ports there is a port building and a building tool called Podrieri. So we use the Podrieri system to build up the binary packages. So the newbies or other people, they do not need to compile the whole port tree or compile an application from the scratch, but rather they can use the binary port tree. In previous the system update, it was actually based on compiling the source, compiling the kernel, everything from zero, but nowadays we have binary system updates available. So you can use FreeBSD update, fetch, install, and you are done. There have been many performance improvement over like the SMP kernel. Then rather than the normal malloc system or memory allocation system, we now use a system called JMalloc, or general implementation of memory allocation. So that was actually built for FreeBSD system, and it keeps up with the timeline of FreeBSD version releases. So there has been some new features like ZFS or Capsicum. Capsicum is actually a sandboxing framework for adding Unix capability modes. Then there have been some improvement with jail system, then RC systems in FreeBSD. Nowadays, FreeBSD actually includes two different file systems, so you can choose in between UFS or the Unix file system over the ZFS or the Zerabyte file system. ZFS was actually from Sun, then it was taken over by Oracle, and FreeBSD always tried to keep up to date with the ZFS versions. So UFS was the traditional old one, the high performance. There were snapshots available. There was supported with journal soft updates. But in ZFS, it comes with more features like file system, volume managers, and RAID. Like you can have an equivalent RAID Z2 or RAID Z3 equivalent to RAID 10 or RAID 5. And it always tries to maintain the release version with FreeBSD. FreeBSD always tries to maintain the updated ZFS codes on their system. So FreeBSD comes with a lightweight virtualization system called jails. You can run multiple tenants on a single kernel. People who are coming from Linux, if you know about KVM, if you're coming from running systems from Docker, you can compare it with jails, but jails is much more better compared to Docker. So for jails, it has got several file system namespace, and if you are running ZFS over on the core operating system, then creating jails using other frameworks like IOCage, it is much more easier. Then if you build up your OS with vMage network stack support, then you can have multiple IP addresses and multiple isolation to run multiple tenants on a single system and on a single kernel. So where you can use the jail system. So if you need a web-based virtual hosting and you need to isolate one tenant or one customer from one other customers, you can use jail-based virtual hosting system. Then you can use for email hosting or service isolation with microservices. Like let's say if you want to run a database in a jail, and you want to use the front end of a website in another part of a jail, and another jail, that makes it much more sense to isolate services from one part of the other in an operating system. The FreeBSD network stack was, if you are looking for TCPIP stack, that was actually developed on BSD and FreeBSD. If you have heard about the BPF or the bulk packet filtering system, or eBPF, the extended bulk packet filtering framework. So you know that actually TCPIP was originally developed and brought in FreeBSD systems. So it is actually still used as the reference implementation for many network protocols. Even so far I remember, the old the earlier Windows versions, those were actually built upon the same ABPF framework or BPF framework. So FreeBSD has full support for both IPv4 and IPv6. There have been some active development on the pluggable congestion control systems, and there are some reference implementation of the HTTP framework. So FreeBSD has some congestion control systems called BBR, or if you have heard about bandwidth bottleneck congestion control. Then there is rack, cubic, new Reno systems. That BBR is actually nowadays in a stable system, and rest of it are also in the FreeBSD kernel. And you can for cubic and new Reno you have to recompile the kernel. So here are some performance improvements of networking in the last 30 years. So if you can look through the throughput of in Gbps and the file size in KB, so how we are performing over some sandstorming using NGINX plus FreeBSD system and NGINX plus Linux systems. So there is on the top image we have got throughput against file size, and on the bottom image you have got CPU utilization against file size. So there have been some massive changes in the architecture and the microarchitecture and the memory optimization and the memory allocation system of the systems. So how we optimize the compilers, then how the CPUs were becoming more cache centered, and then there were NUMA architectures, then DMA and multi-queue systems. Then we are running 10 Gbps, 40 Gbps, 25 Gbps, and 100 Gbps systems. So FreeBSD also have TCP offloading engine or TOE support. So here is a small example of how the improvements of networking went from 1983 to till now. So in 1983, the 4.2 BSD was actually the AT&T Bell Labs BSD version, which started with the BSD TCPIP implementation. Then we have called Carol's congestion control. Then in 1999, we have on FreeBSD 3.1, we started with file. Then on FreeBSD 4.2 there is a difference between FreeBSD 4.2 and 4.2 BSD. As I have mentioned, on 2000, the FreeBSD 4.2 was taken over by the FreeBSD Foundation from AT&T's Bell Lab, and they used a different. They started using a release of a different version. So that is the history of FreeBSD from AT&T BSD systems. In 2001, we added TCP ISN randomization. Then we added TCP thin cache cookies. Then we had in 2003 TCP timer status reduction. In 2004, we had TCP host cache and SSK fine-grained locking. On 2008, FreeBSD added TCP LRO, that is large receive optimize offload, and TCP send offload. So on 2008, we have added TTCP and socket buffer auto-sizing. Then we have added read-write locking, and full TCP offload engine was added into FreeBSD 7.1. So this is a small history of the improvements of networking over the days in FreeBSD systems. So the FreeBSD network stack developers are active members of the transport community, and they are regularly developing and regularly testing new congestion control algorithms to be added into the FreeBSD pluggable framework. And we are trying to add performance improvements on different workloads. We also tie in and try to cope up with the security folks, like when there is any issues with the where or liner encryption systems. And we are also working on some various multiple TCP implementation systems. FreeBSD comes with 3 different firewall systems. One is the native firewall that is called IPFW. There is PF, which is actually the fork of a OpenBSD packet filtering system. Then there is IP filter for fans of the legacy firewall, but these firewalls are well documented and in the FreeBSD handbook and the online manual pages of the operating system. So as said in the jail system that we have multi-IP jail system, we image network stack support for multi-tenant routers. Then we can choose firewall system for IP FWP for IP filter. Then FreeBSD also supports multiple forward information base or FIBs for complex routing. Then we have support for Zebra, Quagga, FRR, BARD, OpenBGPD, or OSPFD as networking as binary packages or from the source. So with vMimage support, we can have a multiple network stacks for multi-tenant system, as I have mentioned earlier. We can combine with jails for the lightweight virtualization system, and each vMimage jail actually gets the choice of a firewall. So you can run a different firewall in different jails. Then you can have multiple FIBs on different jails, and definitely all the security features of a jail you can use along with vMimage in FreeBSD in jails. We also have support for IPsec, then IPv2, and we can also do layer 2 bridging, or we can have combination of multiple links in a lag system, or we can use tag villains. We can have a spanning tree. We sort of have a working MSTP support and definitely a very active transport community. So if we are talking about virtualization of FreeBSD, we do have ready-to-use images of VMware, VirtualBox, KMove, or Hyper-V, which you can download from the FreeBSD download pages. Besides that, we have a native hypervisor called Beehive. If you are if you know about KVM systems in Linux system, so that is something alternative of that KVM in FreeBSD, that is Beehive. In Beehive, you can run Linux, Windows, and FreeBSD images, and this Beehive system is actually also used by macOS as Xhive, and it is also licensed with BSD 3 clause. There are some other security features called MAC, or mandatory access control, with an audit frameworks. So if you want to know like who did what and when, you have to use the audit framework. And MAC also gives you much more in-depth information rather than mere logging of information. So you can send audit trails to remote machines also. Then there is capsicum or capability modes support in FreeBSD, which has much more better than privilege separation. Or so you can also use it for sandboxing or isolating applications with the user space. Then there is system call translation, or sometimes what we try to call Linux personality disorder or Linuxolator. So if you want to run a natively substantial subset of Linux ELF binaries on BSD, you can run it sometimes faster than Linux. So if you want to run Oracle or EagleCAD or other applications which are Linux only, you can use Linuxolator to run those in FreeBSD, and sometimes we have seen Oracle's performance is much more better running on FreeBSD rather than any other Linux system. So this 11.1 release, we did some major improvements to the ZFS system. We also ported Beehive features into ARM processors for ARM v7, and we also ported Beehive to ARM v8. We are having lots of issues with the Wi-Fi drivers in the BSD boxes, and so we tried to add much more improvement and support for Broadcom drivers. So if you want to join the FreeBSD community, you can join the mailing list. You can clone or check out your code from the FreeBSD SVN site. We still use Subversion, but we do have a GitHub repo, and we try to do a commit hook from the Subversion to the GitHub repository. So if you want to change something, you can submit patches to the reviews.freebsd.org. If you are submitting more patches, then you might get a mentor and who will propose you to the core, then grant you a commit bit. Initially, all commit bit will be reviewed by, but soon enough you will be freed from the mentorship. Then you can start finding a mentee, and that's how the community actually runs. So if you want to learn more about FreeBSD, there is the website, there is the foundation, and we have large forums. Then we are very active in IRC2. The mailing list is also very much active. So that would be all from me. So if you have any questions, I'm here. Okay, thank you.
Thanks, Moin.